Yo, 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 yo. A, B, C, D, E, F, G. Problem 2063. Vowels of all substrings. So this is my first attempt trying this problem. My first attempt at this problem. First attempt attempting this problem. If you're watching this video right now, please comment something. I gotta know that I have authentic, real viewers, right? And how am I gonna know that if you don't comment? I get 4 views on these videos. I'm essentially famous, and I don't know who I'm reaching. So leave a comment and tell me why you're watching this video, right? What value does it provide you with to the 4 viewers out there? Anyways, let's get right into this problem. Okay, so you're given a string word. Return the sum of the number of vowels in every substring of word. All right, we know what a substring is, right? Due to large constraints, the answer may not fit in a signed 32-bit integer. Please be careful during calculations. So we don't got to worry about that because we're going to do this in Python, right? We're going to do this in a superior language because we're gentlemen and ladies. But that would be something you probably had to think about if you were coding in C++ or something. Okay, so if we had the word ABA, so we got word equals ABA. So what are all the substrings of ABA? Well, you could have the single substrings of length 1, A, B, and A. You could have the substrings of length 2, A, B. Put this like this. AB and BA, right? And then you could have one substring of length 3 of ABA, right? So the way that I'm doing this here, right, is we have the length 1 substrings here. We got the length 2 substrings here and the length 3 substrings here. And then just something to note about, well, the substrings of a word, right? Like total substrings. If you have something that's, let's just make this as an example, A, B, C, D, E. So this has length 5, right? So something to think about when you do this problem, how many total substrings are there? Well, there's 1 of length 5, right? Which is the whole string. There's 2 of length 4. There's 3 of length 3. There's 4 of length 2, and there's 5 of length 1. So how many are there total? There's 1 plus 2 plus 3 plus 4 plus 5 for a length 5 string. So that means that for the number of substrings for a string S, this looks weird. The number of substrings for a string S equals the length of S, right? Because if for length 5, it's 1 plus 2 plus 3 plus 4 plus 5. So the length of S times the length of S plus 1 divided by 2. So this is a general formula, right? Corresponding to this summation, right? Because that's what this 1 plus 2 plus 3 plus 4 plus 5 is. And if you've ever taken, I don't know, a discrete math class, it associates with this. So that's just something to think about, right? So for 3, we have word equals, the length of word equals 3. So the formula is then length of word. So the number of substrings is length of word, which is 3 times 4 over 2, 12 over 2 equals 6, right? 3, length of 3, what am I doing? So the number of substrings is 3 times 3 plus 1 divided by 2, which equals 6, which we see here, right? So there's 6 substrings in total. 6 substrings in total. And then for this problem, we need to look at each of the substrings for each 6 substrings and determine if there's a vowel in it, right? So the easiest solution for this problem, sorry about going off on a tangent about finding lengths of substrings, right, is to do an n-squared algorithm where we count the number of, we do a prefix sum and count the number of vowels we've seen so far. And then after we do that, look at each ij index in the string, so n squared, each ij index, and find out how many vowels are in each substring. So we look at each individual substring and then find out how many vowels there are and then sum that up. So for ABA, right, we had these substrings. So this is a vowel, so there's one vowel. This is a vowel, so there's two vowels, three vowels, four vowels, five vowels, and six vowels in total, right? So whenever a letter exists, for example, let's look at a different problem, a different example problem, so we can kind of get a better intuition about how this is supposed to work. So if we had A, B, C, D, E, imagine that was a word. Let's first look at all the substrings that could exist, right? So we have the first substring, which is the whole string, A, B, C, D, E. And then we have, well, we'll go the other way. We have all substrings of length 1. So there's A, there's B, there's C, there's D, and there's E. Sorry. Right? So these are all the length 1 substrings. Then there's the length 2 substrings, A, B, B, C, C, D, and D, E. And then there's all the length 3 substrings. The previous ones were length 2. A, B, C, B, C, D, C, D, E. Then there's all the length 4 substrings. So there's A, B, C, D, and B, C, D, E. And then there's the length 5 substring when there's only one, A, B, C, D, E. So I'm drawing it like this for a particular reason, which will become clear in a second. But you'll notice that I've just exhausted all possible substrings of this system. And the easiest way to find those, right, is just to have like a sliding window. So I have a sliding window of size 1. So I grab A, grab B, grab C, grab C, grab D. Then I have a sliding window of size 2. I grab AB, I grab BC, I grab CD, I grab DE, and then I have a sliding window of size 3, right? And then I grab ABC, then I grab BCD and CDE, and I just do that for each size window, right? Because the substring has to be continuous, so I can just grab continuous regions of the system that way and exhaust all possible solutions. So we found an n-squared solution already, but since we don't need to find the actual substrings, we just need to find how many times that vowel, how many vowels we see total in the substring. So what is the problem state exactly? The sum of the number of vowels in every substring. Well, then we just need to find for any letter, right? If it's a vowel, how many substrings will it appear in, right? So we have A here, and A is a vowel. So how many substrings would A be in? Well, A would be in itself as a length 1 substring, this substring, this substring, this substring, and this substring, right? And you'll notice that for each letter that there's this kind of pattern that emerges. So B's here, and here, and here, and here. C is here, and here, and here. D is here, and here. And E is here all alone. Why did that get so much skinnier? Don't ask me. Here all alone. So since A is a vowel, it's in 1, 2, 3, 4, 5 cases, right? So it's in 5 places, so it will contribute to 5 total substrings, right? Let's say that, just for the sake of argument, we know it's not true, but I'm just saying, let's just imagine that C was a vowel. Well, C would contribute to 3, 6, 9 Give it to me one more time. Get low. Sorry. It will contribute to 9 such. It will contribute 9 times, right? Because it's in 9 substrings, right? Because C is in its own substring alone. It's in BC, it's in ABC, it's in CD, it's in BCD, it's in ABCD, it's in CDE, it's in BCDE, it's in ABCDE, right? So it looks like for any letter, if it's a vowel, there's this kind of clear formula, right? A is height 1. It's 1 down, right? You'll notice that A in all of its locations is 1 down, 1 down, 1 down, 1 down. But it's in every row. So it has width 5. So A is a 1 by 5. It's in 1 by 5, so it's in 5 locations. B is height 2, right? It's 2 down, 2 down, 2 down, 2 down. But it's only in a width 4, right? Because there's no, it's not to the left of the system. So it's a 2 by 4. So it's in 2 by 4 of the total substrings. C is a 3 by 3. D is a 4 by 2. And E is a 5 by 1. So what I mean by that, right, is that D is in 4 times 2 substrings. And you can kind of see that just based on the way that I drew the system of substrings, right? So for this problem, the way that I got to this is just kind of thinking about, well, let me draw all the possible substrings, right? And for this system, there's 5 times 6 divided by 2, 15 of them. So let me draw all 15. Now that I'm thinking about it, that's not really important. And then let me see if I can kind of, not sort, but kind of categorize the substrings, put them in locations such that it's easy for me to see if there's a pattern that emerges about, you know, how many times a vowel will be counted. So how many times a vowel will appear in a substring. So it kind of seems like the algorithm for this problem is, right, if we go from I in range, we can start at 0 and then go to the length of word, right? If the word, right, if we're looking at a letter, right, because each of these letters will have a position. So this is I equals 0, 1, 2, 3, 4, right? If the letter that we're looking at, so that would be if word at I is a vowel, I'll just say this, is a vowel, right? If it's a vowel, meaning it's either A, E, I, O, or U, or sometimes Y, or whatever. If it is a vowel, then we'll figure out how many substrings it will end up in. Well, how many substrings will A end up in if it's a vowel? Well, 1 times 5. How do we get that? Well, 1 times 5 is, so we'll say answer, so we'll have some answer variable equals 0, plus equal, well, word of I is 0, so I plus 1 times what? The length of word minus I. Right, so let's imagine that this was an E instead, just for the sake of argument. Or let's say it was an O. So if this was an O instead, that would mean that once we look at I equals 2, so when we look at I equals 2, right, when I equals 2, this will be true, right, because word is a vowel. So then what should we multiply? Well, we should multiply 3 by 3. Well, if I equals 2, this is 2 plus 1, which is 3. Length of word is 5, minus 2 is 3. So you can see that this system works. So it'll give you the number of times that vowel, the number of substrings that it exists in, right? So again, it's all about how you draw the system. When you draw the system like this, it becomes very obvious what the relationship is to a letter and how many substrings it exists in. So yeah, it's all about the way that you draw it. Maybe I should have drawn it differently and then try to think about how I can order things to make it more obvious. But with that, let's go ahead and get right into solving this. So we'll have answer equals 0, right? And then we'll look at I in range length of word. Or let's just enumerate because we're cute. I and then the character in enumerate word, right? So we'll look at the index and the character. If C is in A, E, I, O, or U. Now this is going to be a little bit slower, right? Because it's going to have to search this whole. All right, we'll just make a set. So vowels. Not that it affects the runtime, right? Because it's just going to be confined by 5 operations, but just so that people don't yell at me in the comments. So A, E, I, O. This is making me, don't make me suffer. If it's in vowels, right? So if it's in this set of vowels, so it's one of the vowels, then that means our answer is going to be multiplied by what again? Well, we're going to add in I plus 1 times length of word minus I. Right? Because we just determined that relationship from the number of times this letter exists in a substring from this system, right? Because it had a height 2 and length 4. So answer plus equal I plus 1 times length of word minus I. And then at the end, we just return answer. And then we cry because it doesn't work. Cool. Notice I have not done this. All right, cool. So what's the runtime of this? Okay, well, for time, we do a constant operation here, and then we just need to look at each letter in the word. So if the length of word is n, right? So imagine that n equals the length of word. That would mean that our runtime complexity is just O of n. And then what about space? Well, we have to create 5 characters, 5-character set here, right? And then we have a couple constants. We don't create any stack space, so it's O of 5 plus a couple of something, O of constant, which is O of 1. And yeah, so O of n space, O of n time, and O of 1 space doesn't get much better than that, right? Because we have to look at each character in order to determine if it's a vowel or if it isn't. So it can't even get any faster than this. So this is the most optimal approach. Sure, there's probably some constant factors that makes my code slower than somebody else's, which is why we're seeing this 27% here, right? But yeah, so that's as good as it gets. So I'm going to go ahead and make this even shorter just because I love it when people get mad at me. So this will allow me to make this a 1-line solution if I play this game. Not a 1-line solution, but a 3-line solution. That way I can boast to my friends about how unreadable my short code is. And this probably make it a little bit slower too, I don't know. Made it faster. That's why this is very unreliable. As long as your runtime complexity, space-time complexity is good, don't worry so much about this. Okay. All right, guys. Boom. See you.